Hi everyone, it's Gus from Pi My Life Up, and today we'll be going through how to set up a DS18b20 temperature sensor on the Arduino. Now this project is pretty cool if you want to set up a data logger or just something to monitor the temperatures of a certain room. You could combine this tutorial with another to create a pretty cool smart sensor. For example, you could use something like a piezo buzzer to alert you if a temperature falls outside a certain range. In this tutorial I'm going to be using some LEDs to represent the current temperature of the temperature sensor. If you just wish to stick purely to software, then you don't need to add these. Just to quickly run through what I am using: an Arduino Uno, DS18b20 temperature sensor, 4.7K ohm resistor, breadboard wire, 3 100 ohm resistors, red LED, green LED, and a yellow LED. The circuit for this is pretty simple, and if you don't want the LEDs, just leave that part of the circuit out. I'll quickly describe the DS18b20 temperature sensor now. However, the rest of the equipment is pretty straightforward and probably doesn't need explaining. If you have watched my video on the DS18b20 with Raspberry Pi over at Pi My Life Up, then you will know exactly what this device is. For anyone who hasn't, the DS18b20 is a digital temperature sensor. It is capable of reading temperatures within 0.05 degrees Celsius. It has one wire support, which means it's capable of sharing a single wire with other devices that also support one wire. In this tutorial I am using a waterproof version of the DS18b20, so it simply just looks like a long thick wire with 3 wires sticking out of one end. If you get the device without any extras, it simply looks like a normal transistor. Now let's move on to putting the circuit together. First, connect the 3.3 pin from the Arduino to the positive rail on the breadboard. Also place a wire from a ground pin to the ground rail on the breadboard. Now place the DS18b20 sensor onto the breadboard. Now place a 4.7K resistor between the positive lead, the red wire, and the output lead, the white wire. Place a wire from the positive lead, the red wire, to the positive 3.3 volt rail. Place a wire from the output lead back to pin 5 on the Arduino. Place a wire from the ground lead of the sensor to the ground rail. This is the black wire. Now the next few steps are optional if you want the LEDs. Place a wire from the ground rail to the ground rail on the opposite side of the breadboard. Place the 3 LEDs onto the breadboard. Connect a 100 ohm resistor to each of the LEDs and have these go to the ground rail. Now have a wire come from the following Arduino pins: pin 2 to the green LED, pin 3 to the yellow LED, pin 4 to the red LED. Now that's the circuit all set up, it's now time to move on to the code. If you do come across any problems, please refer to the diagram over at PiMyLifeUp.com. Now by default, the Arduino doesn't have one wire support, so we will need to download and install the libraries for this. If you want some extensive information on what is one wire, then you can check out Arduino's official website. Now getting the library installed is a pretty straightforward process that I will take you through now. Firstly, download the latest version of the one wire library. To do this, head over to PiMyLifeUp.com. and find the tutorial on the DS18b20 temperature sensor. On here, scroll down to the One Library Instructions and click on the link where it says download it here. Once downloaded, open up Sketch. In here, go up to Sketch, select Include Library, and then Add.zip library. Now find the .zip we just downloaded, and it should now say something like Library added to libraries. Check Include Library menu. So now go back up to Sketch, Include Library, and then under Contributed Libraries you'll find one wire. Click on it. This will add a hashtag include at the top of your file and will be added to your Arduino at the next upload. Now, to make things a lot easier, I'm going to suggest installing a library to handle the data that comes from the sensor. This will make it a lot easier than to write the data processing code yourself. If you want to do it yourself without an additional library, then you can find a link here to more information. Alternatively, you can look at an analog sensor such as a TMP36, which is super easy to get going on the Arduino. If you're happy using the Dallas temperature sensor library, then simply do the following. First, download the Dallas temperature sensor library that you can find for download here, back on the tutorial page. Now once that has downloaded, go back into Sketch and repeat the steps we did before. Go to Sketch, include library, and then add .zip library. It should now say something like library added to libraries. Check include library menu. So now go back up to Sketch, include library, and then under contributed libraries you'll find it. Click on it and you'll notice it has added the hashtag include at the top of the file. So now I will explain the rest of the code. If you just want to download the code, you can find it for download back at the tutorial page at PyMyLifeUp. To begin, we need to include both the 1-wire and the Dallas temperature headers so we can use these within the code. Next, we declare all the variables that we'll need to use throughout the script. The first of these represent the pin numbers that the devices are connected to. The float temperature variable is where we'll be storing our temperature value. The lower limit and upper limit variables represent our threshold temperatures. Anything below the lower limit will trigger the yellow LED to turn on. Anything above the upper limit will turn the red LED on. Anything between these two will turn on the green LED. Next, we create a 1-wire object by using our pin we defined earlier, 5. If you have a large amount of 1-wire sensors, it's suggested you split these up across multiple pins. For each, just make a new 1-wire object. For example, 1-wire pin 2 bracket temp underscore sensor 2 bracket semicolon. Next, we create our Dallas temperature sensor object by passing our 1-wire reference into it. In the setup function, we activate the serial interface so we can monitor the output lines in the code. This is also where we need to set up all the LEDs to act as outputs. Lastly, we make a call to sensors.begin. This will set up our sensor so we can start requesting data from it. Now let's move on to the loop. In this segment, we have a few output lines to just let us know when it has successfully requested all the temperatures of the sensors connected to the 1-wire pin. We next store the value from the sensors.getTempC by index 0 into the temperature variable. Now 0 represents the index number. Since we only have one sensor, it will be 0. If we had a second sensor, we would need to use 1 to get the temperatures from that sensor. You can also change this to Fahrenheit by simply changing C to F. We then turn all the LEDs to low so that only the correct LED remains on when we run the next segment of code. We also print two statements, the first being a simple string that says temperature is, and then we print the temperature itself. We finish off this line in the next segment of code. This last section compares our temperature value with our predefined values. Depending on the result, it will turn the relevant LED on. For example, the first if statement says if the temperature is lower or equal to the lower limit, then do this. It will then print the last bit of our text and then turn the right LED on. Lastly, we also delay for 500 milliseconds. I hope this Arduino DS18b20 temperature sensor tutorial has helped you with setting up everything correctly. If I have missed something, made a mistake, or you just want to leave some feedback, then please feel free to leave a comment below. Until next time, have a good one.